Okay, so what we have here is the graph of y equals x squared plus 3x minus 10. So you can see that in red. And then I want to pay attention to where the x-intercepts are here. If I look at these x-intercepts, also known as roots, also known as solutions, look at the x values that you're seeing. An x value of -5, an x value of 2. Didn't we just find those by factoring? We did. So now I want you to see what I have graphed over here in line number 2. So I'm going to turn on this graph and turn off my red one for a minute. Look, red one, blue one, red one, blue one. It's the same parabola. The reason is that trinomial in factored form is x plus 5 times x minus 2. So those are equivalent expressions there. That's why the parabola is exactly the same. Now, does that help you see anything about the roots? So what was this root over here on the right again? What was that one? That dot? 2? Look at this, x minus 2. Interesting. That 2 is one of the roots, one of the solutions. Now the other root over here, this -5, it's kind of connected to this x plus 5, isn't it? Remember how when we talked about transformations, we talked about x minus h? Well, if you rewrote that x plus 5 as x minus a -5, the -5 is telling you what this other root is here. So there's a connection between the graph and finding the x-intercepts, okay? So we call this intercept form. So remember, I've said before, the mathematician's not the most creative namers in the world. So they're like, whoa, this makes it easy to see the intercepts. What should we call it, guys? Intercept form. So, it works. It's fine. So let's go back over to my notes page here, and we are going to add this here. Oops. Oh. So, intercept form. I don't know if I like writing on this or not. Oops, and I can't spell. I don't know. I'm just playing with all kinds of different technology these days to see what I like the best. So, intercept form. Y equals. Now, I want you to leave a space. Well, actually, I'll go ahead and fill in the space. I'm going to put an A right here, but I'm not going to talk to you about it just quite yet. We'll talk about that in a little bit. So in intercept form, it's going to look like factored form, okay? So think factors, and it's going to be x minus something and x minus something, so that we can talk about it. The letters that mathematicians decide to use there are P and Q. And so P and Q, if it's in this form, P and Q are the intercepts. I should say x-intercepts. X-intercepts, also known as roots, also known as solutions. There you go. Okay, so intercept form makes it easy to find the intercepts. And since we can factor, we can put things in intercept form. Okay, so you can find those intercepts there. Now, I haven't talked about the A yet. We'll see that in our next example. Okay, so let's see. For this example, I want to look at the graph of y equals 5x squared plus 6x plus 1. And I'm going to connect that to the quadratic equation, y equals 5x squared plus 6x plus 1. Okay, so same trinomial. I'm having y equals 0. That's why I forgot to put that these are also called the zeros. Let me go back a slide. I am sorry. So let's see. Down here, I said x-intercepts, roots, solutions, also known as the zeros. I knew I was forgetting a word there. Sorry about that. So let's go forward a page. Okay, So we have the quadratic function y equals 5x squared plus 6x plus 1, and then we're going to connect that to solving the quadratic equation y equals 5x squared plus 6x plus 1. Notice we have a 0 on one side. That's important because the zero product property is what we're going for in solving this. So let's see if we can factor this thing. So see, to get a 5x squared, we're going to need a 5x times an x. I'm going to skip over the middle term. To get that 1, I'm going to need a 1 times 1. Okay, now it's a positive 1, which means I need matching signs. Either two positives multiply to give me a positive or two negatives. So I know they're going to match when I look at that back sign and I see a positive. I take a peek back up to the middle term, the 6x, and look in front of that, and it's a plus sign right there. So that means I need matching positive signs here. So there's my factored form. So now we're going to apply the zero product property. Perhaps this factor is the one that gives us the 0. So if 5x plus 1 is the one that's the 0, I can subtract 1 on both sides. And, oops, not that high. Okay, 5x, 5x equals negative 1. Divide both sides by 5. And one solution would be x equals negative 1/5. The other possibility, I'm going to do a different color. How about green? Is maybe this x plus 1 factor. That's really sloppy. Let me fix that a little bit. There. Maybe this x plus 1 factor is the one that's equal to 0. So I could subtract 1 on both sides and get x equals negative 1. So we have a negative 1/5 and we have a negative 1. So those are our two solutions, also known as roots, also known as zeros, also known as x-intercepts. So I wonder how this will look if we graph it. So let me go ahead and pull up Desmos here, turn off that graph. In fact, we don't need those two anymore, so I'm going to get rid of those two. So now, let me turn this on. So here is the graph for y equals 5x squared plus 6x plus 1. Not the easiest thing to graph by hand. So we worked on that. We would find the vertex using negative b over 2a. That gives you an x value. Plug it in to find the y value, and then find points to make the graph. I know you don't love graphing like that. A lot of you are better at factoring quickly than graphing by hand. So once you have it factored, those factors are going to match up to something in our picture. So let's see what we see if we look a little closer here at our x-intercepts. So this one, look at that. The x-intercept there is a negative 1. It's where your graph hits the x-axis, and it's negative 1. Hey, that was one of our solutions. We knew that. Our other one is over here. You see a negative 0.2, which in fraction form is negative 1/5. Hey, we knew that too because that's our other solution that we found by factoring. So let's go back to our notes page now that we know that those correspond to each other. Now, on this last problem that we had here, it was very convenient when we looked at this x minus 2 piece right here to be able to just look and see x minus 2. That's the root that we're going to have. That's the solution. X minus, it was really nice to have the x minus set up and be able to just identify the 2. It wasn't too bad either on this x plus 5 because you could think about that plus sign as being minus a negative, and then you can see your setup of x minus negative 5. So your two intercepts were 2 and negative 5, and they were fairly apparent in the way that that problem was written. That's why we called it P and Q right here. So now I'm going to get to this A part now because this current problem that we're working on, example 2, isn't quite as nice yet. I can see the negative 1. When you look at this x plus 1 factor, if you think about taking this plus sign right here and breaking it down into a double negative. So let me write that as minus a negative right there. So x minus negative 1, you can see that there's your root, your intercept, negative 1. It's not as easy to see in this other factor. So here's what we do to make it more easy to see. So I'm going to take that 5x plus 1 piece. I'll go ahead and bring down the x plus 1 piece just so it's there. So I don't really like that there's this like 5 in front of the x in my first term here. It would be nice if it just said x minus something and I could see the coefficient a little bit better. So what we do is we focus in on this factor and say, well, what if we could pull that 5 out front? So I'm going to pull that 5 out front. It's the distributive property in reverse. I'm going to pull that 5 out front. And if I do that, x, it would be x plus 1/5. Because if you redistribute to check it, 5 times x is 5x. 5 times 1/5 is 1. So it's equivalent right now. I should bring down this other factor just so it's still there. And here's what that does. So now I have y equals 5 times, I'm going to write that plus sign as minus a negative 1/5. And I'm going to write this plus sign as a minus a negative 1. Okay, so here's what you're going to see. Let me write intercept form right below here. A times x minus p times x minus q. So our a value here is the 5. Now a, remember when we talked about transformations, we had a letter A. Same effect in this one. That's why they use the same letter. It affects how tall or skinny the graph gets. I said that wrong. Tall and skinny or short and fat. It's the vertical stretch or compress feature. Okay, so this is a stretched out version. It's 5 times steeper than the normal parabola. The negative 1/5 is telling you one of the intercepts, and then a negative 1 is telling you the other intercept. So that's called intercept form. Okay, well, I think that's everything. So remember, Jesus loves you, and so do I. So do your math.